Now we will see the last of the dividend discount models, the last possible scenario, and it is one in which there is some non-constant growth, meaning the rate of growth in dividends grow for some time at a higher rate than the discount rate, but then eventually it becomes a constant, and I call that the K. So for this supernormal or non-constant growth model, we will see three different examples. When G is higher than the discount rate, the rate of growth in dividends is higher than the discount rate. When the rate of growth is equal to zero, and then when G is negative, so meaning the company is shrinking. So let's go to the first one. So the company wants to or is going to increase or grow at 30% for 3 years. Eventually, it will achieve a long run growth of 6%. We cannot use the constant growth because now G is 30 versus the discount rate of 13 in our example, no? After growth becomes constant, then we can apply the first scenario when we know that there is a constant growth. But for the first 3 years, we cannot use the formula that we used to use, no? The price equals the dividends next year over RS minus G. Therefore, we have to set up the problem in a timeline. So it's going to look something like this. We know that G will be 30% for the first 3 years. After this point, G will become constant. The rate of growth will become constant of 6%, and it will be less than the 13% discount rate. Therefore, from this point onwards, we can use the constant growth case, which is the first, or I think I labeled it A, case A, when we have constant growth for this portion. For this other, when we have supernormal growth or non-constant growth, we have to find the D1, D2, D3 on a manual basis. So recap, we need to find D1, D2, D3, and then we need to find the value of the company from this point until the end. So in order to find D1, we know that D1 equals dividends just paid times 1 plus G. They will be 30% larger than this dividend just paid. So we go to our spreadsheet here and we find that this is the same as 1 plus 30% or zero point 0.3. And we find it to be 2.6. Then we repeat the process to get D1, D2, D3, which also grows at 30%. All of these are growing at 30%. After this point, D4, they grow at 6%. So here is where we reach. Why do we need D4? Because we're going to find the terminal value or the horizon value at this point. So let's get D4 will be equal to this, but I can copy and paste it and then edit here because it's growing at 6%, not at 30%. So we found D4 as well. Once we have D4, we can estimate the intrinsic value, or we call that the terminal or horizon value, the value of the company from this point until the end. So this is using the first case when there's a constant growth formula. So using the formula, the terminal value or the horizon value at this year 3 would be dividends next year over RS minus G. So we're looking at this, what's the value? We found dividends in year 4, so we have D4. And the last thing we're needing now is to plug in the numbers. And we say, well, D4, which grew at 6% over the prior year dividends, divided by RS minus G, our discount rate. We do that and we find the horizon value of 66.54. The last thing we have to do is to get all the we have found now what's the value of the company after year 3, and we also found the value of D1, D2, D3. Therefore, we need to plug in those numbers and get the present value of these in order to estimate the intrinsic value per share. This is what we know so far. We know that the price after from this year 3 onwards is about 66.54 per share. But we also know this is part of the valuation because this will be a dividend that the shareholder is entitled to receive. Also this one and this one. Dividends just paid are assumed not to be held, or we assume when it's D0 that we just missed this payment. So this is not part of the valuation. However, these three cash flows will be part, and this 6654 will also be part. Why is not D4 part of the valuation? Because we use D4 just to find the terminal value. So D4 is already incorporated into the terminal value at time 3. So to sum it up, we need to find the present value of an even cash flow. So we put this in a table. So we have the periods and we have the different cash flows. So if you remember, cash flow 1 was 260. So we put 260, 338, and then we put this is dividend 3, which is 4394, and we need to also put the intrinsic value once the company growth becomes constant, which is 6654. Since they are both expressed in the same time period, so they are both in year 3, we can add this, and that's what I did in the Excel file. So we just do cash flow 1, 2, dividend 2, and dividend 3, the addition of dividend 3 plus the intrinsic value we just found over here, the 6654. To this, we need to find the net present value. We need to discount or find the present value of this. So we do the function called net present value, and we use our discount rate of 13%, and we start in period 1. We don't add anything. In theory, this is the way to do the net present value calculation. Um, and we find that the intrinsic value per share based on this model is $54.11 per share. So what is the dividend yield? The dividend yield is just dividends in year 1 divided by the expected price. In our case, it's 54,481 if you remember. We have a 260 divided by the intrinsic value of 54, and then if we know that the total yield or total return is 13%, we just do 13 minus the dividend yield we just found, and that's what we do here. And the dividend yield is non-constant. Capital gains yield is not the same as G. In the constant case number 1, we saw a couple of minutes before, G was the same as the rate of growth in dividends, but in this case it's not. And then if you want, you can watch another one, click on the slides, and you will see another example which will help you in solving these problems. And we have a case of suppose the second variation of the non-constant growth is that when we have a zero rate of growth in the first few years, and then it grows at 6% forever. So for this point, we know that the dividends just paid are $2, were $2. We do not include this in the valuation. We just use it to find D1, D2, D3, which always be $2. And from this point onwards, growth becomes constant at 6%. So we need to find the the terminal value or the horizon value as of year 3. Simply plug in the numbers. We have two dividends just paid, $2. We missed this payment, but we needed to find the 1, the 2, the 3, and then at this point it's growing at 6%. So we find the horizon value as of year 3. So we use D4, which is found here, divided by the discount rate minus G. Now G is 6%. So we use the 13% minus 6%, and we get the horizon value. Finally, the next step would be to find we found the horizon value, so we need to find the present values of these uneven cash flows. So we have to find the present value of this, present value of this, present value of this, plus the present value of this. Remember, D4 is not part of the calculation because it has been already included in the horizon value or the terminal value of year 3. Similar to the previous case, we find D1, D2, and then for D3 we add the $2 in dividends plus the intrinsic value we just found here, which was $30.29 at the end of year 3. And to this we need to find the present value. In order to find the present value of an uneven set of cash flows, we use the discount rate of 13%, and then we use the starting cash flow 1, find the net present value, and we find that this is the intrinsic value per share based on our model. If you see, the one here is due to rounding differences, but it's the same for the non-constant growth. What would be the dividend yield? Would be $2 divided by the intrinsic value that we just found. And the capital gains is just the difference between one and the other. And after growth becomes constant, G will be the rate of growth in capital gains. So the same G will be also the capital gains yield, and the dividend yield will be $7, 7%, I mean, by the difference between one minus the 13% minus the 6%. Finally, last case is we have a stock that is not growing. So count, does the stock that is not growing have any value? And I usually use the example of Sears. No, it's stock that is dying or closing stores, but every year you have negative growth. And then does it have value? Yes, it does, because it still has some assets. So this stock just paid a dividend of $2. Dividends next year will be 6% less because remember G is constant at a negative 6. So every year 6% less in growth. So we use a formula, these are the inputs. We have D1, which is 188 divided by 13 minus 6%. So when we solve this is what we find. We have the dividends in year one divided by RS minus G. A negative and minus a negative will be a larger number. So this should be the intrinsic value per share for a stock that has negative growth. It does have value because there have assets and still produces some income, even though dividends are shrinking. And here's the answer in a nicer format that we use. And then what is the dividend yield in this case? We have 188 divided by 989. And the capital gains yield will be just the difference between 13 minus the dividend yield which is found. And it will be a negative, capital gains yield will be negative 6%. And the stock still has a dividend yield large as compared to the loss in capital gains, and our total expected return will be still the 13% return that we hope. So this concludes the first case when we have dividend discount model. Now we're going to move on to the corporate valuation model.